Hi everyone. Today I'm going to talk about how to name chemical compounds, or another name for it is nomenclature. There are two different compounds in the concept of naming. If you are able to differentiate between these two compounds, you have done half of the way of the naming basically. So there are two types, as I said. One are ionic compounds. Ionic compounds are from metal and are metal plus non-metal, and molecular compounds are non-metal plus non-metal. Example of the ionic is NaCl. An example of molecular compounds are CO2. So let's go to the periodic table. I will provide you a periodic table which has this ladder. The left side of this ladder, all are metals, even though these two periods in the bottom of the periodic table, which are lanthanides and actinides, all are metals. The right side of this ladder are all, we consider them all non-metals. So if I talk about the ionic compounds, an example was NaCl. Na is here, right? Is metal because it's the left side of ladder, and Cl is non-metal because it's the right side of ladder. So the compound NaCl will be what? Ionic compound. And for carbon dioxide, which is molecular compound, carbon is non-metal because it's in the right side of ladder, and oxygen is also non-metal, which is in the right side of ladder. So both of them are non-metal, so CO2 will be molecular compound. So the first question you're going to ask yourself when you want to name a compound is this compound ionic or molecular? After you be able to understand which one is ionic, which one is molecular, then you should use the naming that is correlated to ionic compound, if it's ionic compound. If it's molecular compound, you should choose the method that for naming molecular compounds. So ionic and molecular compounds have different methods of naming or nomenclature. So let's see which of these are ionic and which of them are molecular compounds. Calcium chloride. So calcium is metal because in the left side of ladder. So I would recommend you put a periodic table in front of you and do it with me. So calcium is in the left side of ladder in the periodic table, and calcium is and chlorine from the right side of the ladder. So that would be ionic compound. Fe2S3, Fe from the left side of ladder, and sulfur is from right side of ladder. So that's the ionic compound. C is from right side of ladder, and hydrogen is non-metal, although it's in the left side of periodic table, but we consider hydrogen as a non-metal. So CH4 here is covalent or molecular compound. Another name for molecular compound is covalent compound. What about PF3 here? P is phosphorus, which is in the right subladder, and fluorine also is in the right subladder. So this is molecular compound or covalent compound. So that's what we had. And let's see how we should basically put the metal and non-metal character next to each other in a compound. Always the most metallic character sits in the left side of the compound. Again, always the most metallic character sits in the left side of the compound. So look at NaCl. Na is what? Is it metal or non-metal? Is metal, right? Because in the left side of ladder. and chlorine is the right side. So our metal is most metallic, right? So that's why Na should sit in the left side. So we don't have at all Cl and A. Okay, we cannot write because Cl is non-metal. So we cannot write the non-metal first if you have ionic compound for sure. But if you have a molecular compound which are all non-metals, we should write the one which is most metallic character in the left side. We should write down or the one with the most metallic character in the left side of the compound. If you look at this table, you will see that from left to right of this table, metallic character decreases. Okay, decreases. So always the one in the left side sits in the left side. So let's do an example. For example, CH4, C is in the left side, so it has a more metallic character. So its metallic character is more than, basically compared to hydrogen is more, because from left to side of this table, metallic character decreases. What about PF3? P is more metallic character because P is in the left side of this table compared to fluorine. Generally, in the periodic table, from left to right, metallic character decreases, and from top to bottom, metallic character increases. So that's the general rule for the metallic character. So did you hear that oxygen and magnesium went on a date? Oh my God, right? So, but this is not right. OMG is not right, because if we make it, assume it's a compound, O oxygen and Mg as a magnesium, their way of writing is not right. Why? Because magnesium is most metallic than the oxygen, because in the left side of the periodic table, in the left side of ladder, and is metal. So we should write MgO. Okay, so let's first see how we can basically write a formula for ionic compounds. So as I said, the first thing to do is first ask this question from yourself. Is this compound ionic or molecular? Now let's find a formula for ionic compounds. First, we should review the element that forms ions with the predictable charges. So we should first know that what charges these elements have, or basically making a compound. And ionic compounds always contain positive and negative charges. In the chemical formula, the sum of the positive and negative charges equal to 0. So the positive and negative charges always cancel out each other. This is the periodic table which tells about all the charges of the elements. These are the ones that only make only one type of charge, and you should memorize them. So lithium and sodium, potassium, rubidium, and cesium are from group 1A and always make 1 plus charge. Group 2A are 2 plus charge, and so always 2 group 2A make 2 plus charge in a compound, of course. So alone they don't have a charge, but they come in a compound, they make these charges. So we are basically talking about the charge of these elements in a compound, inside a compound. Group 3A, we emphasize on these elements, make 3A 3 plus charge, 5A 3 minus, 6A 2 minus, and 7A or halogens 1 minus. So you can pay attention that the ones in the right side of ladder are all non-metals, and they all always are negative charges. Okay, but whenever you have metals in the left side of this ladder all are making positive charges, except hydrogen. Hydrogen makes positive charge, although it's non-metal. Okay, so that's exception basically. So we said that we should first make sure we have the correct charge of that element. So aluminum, based on the table I showed you, is group 3A, right? So put a table in front of you and come with me. So group 3 have always 3 plus charge. So always is 3 plus. So I'm going to put the charge of aluminum on top of it whenever it's making a compound. And oxygen is group 6A and always is making 2 minus charge. So always the rule to make a ionic compound formula is just cross. So the charge of the positive charge will be the subscript of the another element, which here is oxygen. So the charge of aluminum is going to be the subscript of oxygen here. And the charge of oxygen becomes the subscript of aluminum. We call it cross rule. So always remember cross rule. The charge of one element becomes the subscript of another element. Also, the reverse works. It means the subscript of element is the charge of another element. So the subscript of the one element will be the charge of another element. So again, I want to review. We write a symbol for the elements and the charges of them. Then we make sure that we put the charges of them. Again, make sure the charges are correct. And then we basically do the cross. And here would be the compound L2O3. Is here it says, if possible, in the number 3, if possible, reduce a subscript to give a ratio with the smallest whole number. For example, you say how? For example, for the Mg2 plus O2 minus, if you do the cross rule, we make Mg2O2. But because they have a ratio of 2 of each other, we can cancel out the subscript, and the final correct answer would be MgO. So pay attention. Usually when the compounds that are made with oxygen have this basically. So, and also the compounds that have a 2 plus or 4 plus charges should kind of pay attention to it. Is it simplified or no? So let's find some charges of this. So calcium is from which group of elements? Is 2 plus. So has a 2 plus, and also we can find out the subscript of chlorine is the charge of calcium. So there are two ways to find the charge of calcium. One from the subscript of chlorine, and one is from, because the calcium is from group 2 plus. Also, the subscript of calcium is 1, so the charge of chlorine would be -1 or 1 negative. And also we know that group 7A have a always -1 charge. You might ask, okay, how I should know that the first element on the left side always is +1? Because always if you remember, we said that always the one in the left side is the most metallic character. So always metals are getting positive charges. And always the right side always get the negative charge. Okay, so let's do the second one. Sodium is from group 1A, so the charge is 1 plus, or we can say the subscript of bromine is 1, so the charge of sodium is 1 plus, and the subscript of the sodium is 1, so the charge of bromine will be 1 minus or 1 or minus 1. And also we know that bromine is from group 7A, which has a -1. Okay, let's go here. So that's they gave us a charge and they want us to find a compound for its charges, like a previous slide. So the charge of iron is 3 plus, so it's going to be the subscript of sulfur, and the charge of sulfur is 2 minus, and so the subscript of iron will be 2. So we do the cross rule. The same for potassium and iodine, which is gonna be Ki. So let's see how we can name this. So now we kind of know how to write the formula of ionic compounds. We did it in the last slide. So let's see how we can name the compounds. The first one would be basically how to name them. The first rule would be ionic compounds with one type of charge. Basically, what I talked about in the previous slides, group 1A, what are the charges of group 1A are 1 plus, right? Group 2A are 2 plus. Group 3A are 3 plus. These always are one type of charge. They cannot have more than one type of charge. They cannot have, for example, sodium always have a charge of 1 plus. Never ever you can find sodium 2 plus. Okay, never. So that's why we call it as a one type of charge. Ionic compounds with more than one type of charge. The example is iron. Iron is can be FeCl3 or FeCl2. So if you remember, based on the rule, a cross rule, we know that the subscript of chlorine is a charge of iron. So here the charge of iron is 2 plus, and here the charge of iron is what? Is 3 plus. So we have two different charges for iron. So we want to know how we can name this. Usually this happens in the transition metals. The third one would be ionic compounds having polyatomic ions. For example, you might have heard of sodium carbonate. So the carbonate here, or CO3 here, is the polyatomic ion. And we're going to talk about how we're going to name it. I'm going to introduce it to you and name this compound. Again, I go back to the question. Make sure before you start writing down the name of it, make sure if it's the compound ionic or molecular. So this is the summary of the charges we should basically memorize, and I had in the previous table, and I want to just emphasize zinc always have a 2 plus, and always silver has a 1 plus. So that's these two also part of one type of charge. These are the ions more than one type of charge, like iron I talked about, like chromium has a 2 plus, 3 plus, cobalt 2 plus, 3 plus, copper, tin, mercury, and lead. I'm not going to give you more than this in the exam, okay? So I want you to memorize this. Please pay attention that for mercury, the mercury one is written Hg2 2 plus. So always this 2 is part of this Hg2, and then mercury 2 is Hg2 plus. How they put a charge next to them? Make sure they put the charges on top right in the Roman numeral in the parentheses. Okay, that's what we're going to talk about in the next slides. And I don't want you to memorize the older names. I'm not going to give it in the exam, but you can basically, if you want, you can read it for your information. And these are polyatomic ions. You can basically, I'm going to go over it, and I'm going to provide this in the exam. Okay, let's first see how we could name ionic compounds with one type of charge. For the one type of charge or invariant charge, we first write the name of cation, which is a metal, and plus name of anion, plus, which is non-metal, plus ID. For example, the most famous one that you have heard is sodium chloride. Because sodium has only one type of charge, or plus one, we don't need to emphasize the charge of it. So we say, just we write sodium chloride. You might ask, why IDE? Because the name of the basically non-metal is chlorine, for chloride. I mean, for Cl, it's chlorine in the periodic table. But we remove ion E and we add IDE to it. So it will be sodium chloride. Why? Because whenever in this compound, I told you that sodium is 1 plus and chlorine is 1 minus. Because chlorine is 1 minus, the name for anion will be IDE, added IDE to it. So it will be chlorine will be chloride because it has become an anion. So these are the name of anions that you should also memorize them. Let's see how we can name these compounds. What's the name of this? So we know that this is ionic compound because it has a metal in it. And then how I name ionic compounds, I know that this is one type of charge because it's group 2A. So it's going to be calcium chloride. What about this one, the second one? That's the potassium. I know potassium is from group 1A, so it has only one type of charge. So I'm going to call it potassium iodide. Potassium iodide. Okay, so let's go to the second type of charge, ionic compounds with more than one type of charge. For the more than one type of charge, or when the charges, for example, iron, like I talked about it, iron can be 2 plus or 3 plus. How we name them? We should emphasize on the charge of the iron because for example, imagine we have two brothers. So the first brother, they call them Robert. They call him Robert. But the second one, they call him Robert Junior. Because if they call the second one Robert, they get confused, right? Okay, which Robert are you calling about? So the same thing, we should emphasize on the charge of iron here, because we have two type of charges of iron. So let's talk about how we name it. So we should write name of cation, which here we have iron, charge of cation in the Roman numeral in parentheses. Here we have iron 3Y because the subscript of chlorine become the charge of iron. And it's going to be the name of anion, which is going to be plus IDE. Iron 3 chloride. So these are the elements that they have more than one type of charge, and this is how they write the charge of them in Roman numeral. So this is chromium 2 plus, they put the 2 in front. So these are the charges them in Roman numeral. So let's name this. What do you think is the name of this compound? So we know this ionic, right? Because it's metal and non-metal. Then I know this is more than one type of charge. So I'm going to emphasize on the type of it, or the charge of it. It's going to be iron 3 sulfide. What about this one? We have that's the chlorine, the subscript of chlorine become the charge of copper. So it's going to be 1, copper 1 chloride. So we don't really write down the charge of anion here, right? Because we have already included as IDE. That's how it says whenever it's negative charge, we already included in here. chloride. So what about the third one? Chromium 2 bromide. You can pause and try to do it before to look at the answer. Tin 4 chloride is gonna be SnCl4. What about iron 2 oxide? That's the tricky one. I'm gonna give it in the exam, so pay attention here. Iron here has a 2 plus, right? So it's gonna be Fe2 plus. What about oxygen? It's 2 minus. So it's going to give me Fe2O2. But because they are both the same ratio of 2, they're gonna cancel out and they're gonna give me FeO.